Hello and welcome to my channel. In today's video, we are going to be solving this beam problem that has four forces acting on the beam, and we are also going to be figuring out the forces that are opposing the forces that are pointing down. After that, we are also going to be graphing the shear force and the bending moment. By the time you are done watching this video, I guarantee that you're going to learn how to graph the bending moment in 2 weeks. So let's get right into the video to solve this problem. Before we perform any calculations, let us know that there are 3 equations that we need in order to solve this problem. But before we can start to solve any problem, we need to apply Newton's third law, which states that for every action, there is an equal and opposite reaction. As you can see, we have a pin support here. This pin support is going to be having a vertical force because it is a pin support. As you try to push down this beam, it's going to create that vertical force here, and it also has a horizontal force too as well here, right? Because as you try to push this beam also on the right or on the left, it's going to also create a horizontal force as well. And we also have another pin support here, which is also going to have a vertical force and a horizontal force. The reason why this was selected as the direction of the force is because this is to the right. So as the force here is to the left, this should be going to the right in order to cancel the forces out, right? Now we have 2 vertical forces here. Let us call this FA and we call this FB, right? We need 3 equations to solve this problem. The first equation is to sum the forces in the x direction, right? If we call this FAX and we call this FBX here, so summing the forces in the x direction, we're going to have the sum of the forces in the x direction is going to be equal to, we have a force that is going on the right here, which is FAX. So we have FAX. We want to set that equal to the force that is also going on the left, which is FBX. And notice that apart from these 2 forces that are acting in the x direction, we don't have any other force that is acting in that x direction. So because of this, since we're not given the value of FBX or FAX, these 2 forces cancel each other out. So we are going to ignore the forces in the x direction and solve for the forces in the y direction. So that equation is going to be the sum of the forces in the y direction should also be equal to 0 here, and adding these forces together, we have FA and FB pointing up, so it's going to be FA plus FB is going to be equal to these forces that are pointing down. Yeah. So we have 40 kilonewton force pointing down here. Kilonewton force, right? So this is our first equation. We're going to be using these equations later. And notice that we have 2 unknown forces, FA and FB, right? So we have to find the magnitude for each of these forces that are opposing the 40 kilonewton force that is coming down. So to solve for that, we need the moment equation and also set that equal to 0 to find the moment about FA and FB here, right? So taking the moment about FA, that is going to be the moment, the sum of the moment at point A here. Considering point A is going to be equal to 0 here, right? Direction. And so we are going to consider this direction at point A, which is the, I'm going to start from this direction, 10 kilonewton force that is positive going in and the clockwise direction as negative, right? So in this case, we have 10 kilonewton force that is going in a clockwise direction. So therefore it's going to be negative 10 times the distance away from this FA. That is also 1 meter long, right? So this 10 kilonewton force is going to be multiplied by this one here. And we also have this 10 kilonewton force that is going in the clockwise direction too as well. So because of that, it's going to be negative. Say negative 10. We are going to multiply that by the distance away from FE here, right? From this E point. So the distance away from A here to this force is 2 meters. And we come to this force. This is also 10 kilonewton. It's going to be multiplied by 1, 2, 3. 10, 3. And the second to the last force that we have here is this 10, also going in the same direction. And this time we have 1, 2, 3, 4. Minus 10 times 4, right? The last force we have here is FB, which is creating an anti-clockwise rotation. Since it is rotating in anti-clockwise direction, then we are going to consider that as positive. So in that case, we're going to have 1, 2, 3, 4, 5. 5 F B here. We set that equal to 0. So summing them, we're going to have 10, 20, and this 5 here. We're going to have 100. 5 FB is equal to 100 kilonewton. So dividing this by 5, FB is going to be equal to 20 kilonewton. So now we can take this value and substitute it into this equation and solve for FA, right? So doing that, we're going to have FA plus FB. That's going to be equal to 40 kilonewton, right? And now substituting the value, we have FA here, 40 minus 20. So that is going to give us 20 kilonewton too as well. Now the next thing that we have to do is to graph the shear force and the bending moment. But remember, in this video, I promised to show you 2 techniques that you can use to graph the bending moment. The first technique is what I call the moment technique, and it is in this form. So what we have to do, so the first step is to take a moment at every point that a vertical force is acting on the beam, right? So now in this case, considering this FB as the first point, right? We cannot take a moment about point B. We are going to ignore this because there is no distance away from this FB, right? But if we consider taking the moment at point E here, there is a distance from this FB to this E, right? So we can take a moment from this E here. And this one too as well. There is a distance from this B to this D, and also from E to this D. So therefore, we can take a moment about D here, continuing until we can reach at point A, right? So after that, that will be the point for our bending moment. So let's continue from the left to the right. So the right, as you can see here, let us consider taking our moment about point A here. So considering taking our moment about point A, that there is no force on the left, so we're not going to consider point A. And as for point B, we have a force on the left here, right? And that force is FA. So we're going to multiply FA by the distance away from this point B here, right? That is going to be the moment about point B. And about point C, we're going to multiply these two forces that are on the left of point C. We're going to continue like that until we reach to the force F here, right? So now let's try to take the moment about each of these points. So now we have the moment about A. That is going to be equal to 0 because there is no force on the left. And the moment about point B, this point, there is one force here which is going in a clockwise direction, and that is going to be negative. The force here is 20. We already saw for that already. And this is also 20. So it's negative 20 times the distance, which is 1, giving us negative 20 here. And at the moment about point C, we have two forces. This is going in the anti-clockwise, and this is going in clockwise. So like that, we're going to have moment at C is going to be 10 times 1, 20 times 2. It is minus 40, and it is 10. So the result here is minus 30, right? So the moment about point D, here we have three forces. 2 is going in the anti-clockwise positive, and 1 is going in the clockwise, which is going to be negative. So we have 10 times the distance away from this is 1. We also have another 10 times the distance away from this is 2. And we have 20 here, right? Since it's going in a clockwise negative. And the distance away from this is 3. And this is going to give us negative 20, right? And we have point E. Now let's try to do this. This is 10, this is 10, this is 20, and this is 60. So 30, 60, this is going to be 32 as well. And the moment about point E here is going to be, these three are going in an anti-clockwise positive, and this one is going in a clockwise negative. We have 10, the distance here is 1. We have another 10, the distance away is 2. We also have another 10, the distance away is 3. And we have another 10 again. 10 here, the distance away is 4. And we have at point E, we stop here, and this last one, that is negative 20, the distance away is 4. So adding this together, we have 30 here plus another 30, 60, and we have 80 here. So that is going to give us negative 20. So let's continue. The moment about this one, we have moment about point F. We have 10, 1 plus 10, 2 plus 10. Distance away here is 3. We have 10 again plus 10. The distance away is 4. Then we have this 20 kilonewton force that is going in a clockwise direction, 20, and the distance away is 5. The distance away from this 1, 2, 3, 4, 5 is 5. So here we have 10, we have 20. This is going to give us 30. Then we have 30 here as well. So that is 60. We have 60 and we have 40 here. 10 times 4, 40 plus 60, that is going to give us 100. 100. Then we have negative 20 times 5 is going to give us 0. I'm sorry. So these are our point on the graph of the bending moment. We have this, 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 and we have this. So plotting the graph, we first start with the shear force and then graph the bending moment by using these points. So let's redraw this figure. Now, since we have redrawn this graph, since there are no forces acting in the x direction, we are not going to have a graph of a normal force. So this one will cross this one, and for the shear force, we have forces acting in the y direction. And the first force here is 20 kilonewton long, right? So this takes us up because it's pointing up. It's 20, right? And the distance from this 20 kilonewton force to this 10 kilonewton force, there is no other force acting in between. So therefore we're going to have a straight line there pointing down, and in this case it is negative, so it's going to be added to this 20 kilonewton force, which is going to take us down to 10. All right, and from this 10 to this 10 again, there is no force. And at this point we have 10 kilonewton force also pointing down. This is going to take us to 0. All right, and we have no force. We also have 10 kilonewton force pointing down, 10 here. This takes out negative 10, and from this negative 10 to this force here, there is no other force that is pointing in that direction. So we go there, and the force is pointing down. It's going to be added to this one. Since it is negative, it's also going to be added to this negative 10, which is going to take us to negative 20. Negative 20, right? So we don't have any force. The last force is 20 kilonewton, which is going to take us back to 0. If we had not reached to 0, then which means there was a problem during the calculations of the moment. So this is how our graph is going to be for the shear force. So now, how are we going to draw the graph of the bending moment? Know that we have already found our precious point. So these are the points that we're going to be plugging here. So let us bring back the points. So let us plot the point on this graph. The first one here is 0, yeah. And the second one is -20. But how are we going? Since we have a straight line, as we said in the previous video, that if you have a straight line, the next graph that is going to be under that is going to be an inclined line, and the next graph is going to be a parabolic line if the graph is an inclined line, and the next graph under this one is going to be a curved line, right? So considering that, we are going to have an inclined line, since here is a straight line. So in this case, we have an inclined line here, and the next point is -30. We have -30 here, and the graph of that is also an inclined line. So we're going to have an inclined line. The next point is also 30, so we have -30. So in this other section, we have the point here, the next point here, which is -20, -20, right? And the graph of that is an inclined line, so give that inclined line to it. And the next graph here, as according to our point, is 0, so this takes us to 0 here, right? So this is going to be the graph of our bending moment. It's going to be the graph of our bending moment, right? Since at the beginning of the video, I promised to show you two techniques. This is the first one, and the second technique is going to be very interesting. So let's get started with that. So we'll have to redraw this beam again in this section so that we can be able to graph it here. We are also going to cancel this normal force. For the shear force, we are going to use the same procedure, but as for the bending moment, that is where the technique will come about. As for the bending moment, it's going to be the negative integral of the shear force. Let's say, for instance, if you have your graph of the shear force in a positive region here, it is going to reflect in a negative region of the bending moment graph, right? Since it is positive here, it's also going to be negative here. If it is negative, it's going to be positive. If it is negative here as well, it's going to be positive on the graph. And the bending moment is also going to be the area under the shear force graph. For instance, this portion of the graph is 20 meters long. That is going to be multiplied by the base of that graph. And the base of this graph is 1 meter. So 20 times 1 is going to give us 20. Since it is positive, it's going to give us a negative graph. So in this case, we will have -20 here. -20. Next, the height of this graph is 10. Multiplying that by the base is going to give us 10 as well. So since it is positive, it's also going to be negative. And adding negative to negative is going to give us the same negative, but this time we are going to add the numbers. 10 plus 20, that is -30. So -30 here, right? And here we have nothing. The height is 0. So 0 times 1 is just 0. We continue this way, right? And since these graphs are all straight line, we are going to get an inclined line here, right? And the next one, it is in a negative region. know that since it is in a negative region, it's going to be going into the positive region. So the height of that is negative 10. Multiplying that by the base here, the distance, is going to give us negative 10 as well, since the distance is 1. Multiplying that by negative, because we said the negative integral. Alright, so multiplying that by negative is going to be positive. So adding positive 10 to negative 30 is going to give us negative 20. Negative 20. And the graph is an inclined line. The next one here is negative 20, and the distance is also 1. So multiplying negative 20 by 1 is 20, and multiplying that by the negative here is going to give us positive. So adding positive 20 to negative 20 is going to take us to 0. Now we have our graph. This is going to be the graph of the bending moment. So you can help me out. This is a new channel. You can subscribe to my channel and click the notification bell so that anytime I post video, you can get notified. Have a wonderful day.